Welcome to Session 8, Perimeter of Polygons. We will build the idea visually, solve a complete example, and finish with a short independent check. By the end, you will be able to trace the complete outside boundary of regular and irregular polygons. Find missing side lengths from aligned totals before adding. Keep perimeter in plain linear units and separate it from area. Keep the diagram, the calculation, and the unit connected at every step. Start with the concept visual. The opposite rectangle sides contribute to the full boundary. The every outside triangle side is included once. Read every label as evidence about what is known, what is unknown, and which measurements actually belong in the model. Here is the central reasoning. An irregular garden may have internal planting lines, but fencing follows only the outer edge. If 12 minus m total width is split into 5 meters and an unlabeled segment, that missing boundary segment is 7 meters before the perimeter is added. Perimeter is a boundary walk. Each exposed segment is counted exactly once, including short recessed edges, while interior seams are ignored unless the context says they require material. Estimate with a nearby rectangle or familiar benchmark. The estimate does not replace the exact calculation. It tells you whether the exact result belongs in the right neighborhood. Now add a precision check. For every area or boundary problem, identify exactly which segments form the base, height, radius, diameter, or outside edge. Convert units before combining measurements. Keep full precision during the calculation and round only once at the end if the context requests a decimal result. A complete line of work should make the diagram, formula, substitution, arithmetic, unit, and conclusion easy for another learner to audit. Use this repeatable method. First, place a starting dot on the boundary and move clockwise around the figure. Second, record each outside segment exactly once and ignore interior divider lines. Third, infer missing horizontal or vertical pieces from matching overall dimensions. Finally, add all boundary lengths and perform a second trace to verify the count. Do not skip the final check simply because the calculator produced a number. Let us model a complete example. A regular hexagon has side length 8. What is its perimeter? Step 1 is to organize the information. Place a starting dot on the boundary and move clockwise around the figure. Step 2 chooses and sets up the relationship. Record each outside segment exactly once and ignore interior divider lines. Step 3 carries out the mathematics. A regular hexagon has 6 equal sides, so perimeter is 6 times 8 equals 48. A useful check is to perimeter add side lengths. The answer is 48. Now verify the result against the original wording. The quantity, numerical size, and unit must all make sense together. Now it is your turn. A regular octagon has side length 5. What is its perimeter? Write a formula or relationship before calculating, then use the next 6 seconds to finish your reasoning. The model answer is 40. A regular octagon has 8 equal sides, so perimeter is 8 times 5 equals 40. A useful check is to perimeter add side lengths. Use this coaching check as well. Point to each side while reading your addition expression aloud. This catches both skipped and double-counted edges. Session recap. First, place a starting dot on the boundary and move clockwise around the figure. Next, record each outside segment exactly once and ignore interior divider lines. Then, infer missing horizontal or vertical pieces from matching overall dimensions. Finally, add all boundary lengths and perform a second trace to verify the count. A strong geometry solution is more than arithmetic. It identifies the requested quantity, represents the structure, calculates carefully, and checks the meaning of the result. Carry that full habit into the next session.